The survival industry convinced Americans they need $40,000 concrete bunkers to survive fallout. Reinforced walls, steel doors, NBC filtration systems, the whole package was marketed as the only real protection. But declassified research from Oak Ridge National Laboratory tells a different story. During the height of Cold War civil defense testing, engineers discovered that a shallow, earth-covered arch built by ordinary people with local materials outperformed reinforced concrete bunkers on the specific metrics that actually matter, blocking gamma radiation and surviving blast conditions. The design costs under $500. It uses an arch framework of timber, bent pipe, or sandbags covered with 30 inches of compacted soil. It breathes naturally through passive ventilation with no electricity, no filters, and no moving parts. And it achieved protection factors of 200 to 500 in field testing, 5 to 12 times the federal standard for adequate fallout protection. Today I am walking you through the Earth Arch shelter, the Cold War design the bunker industry never wanted you to see. Cold War governments pushed concrete fallout shelters hard. Families spent thousands on what turned out to be sealed concrete coffins. Too hot, too damp, too airtight. Documented cases exist of families abandoning their bunkers within hours due to heat buildup and carbon dioxide accumulation. Concrete itself was the problem. It cracks under blast pressure, and Nevada test site data from the 1950s showed reinforced concrete structures developed stress fractures at 5 to 15 pounds per square inch over pressure, exactly the range you would encounter at survivable distances from a detonation. Those cracks create pathways for radiation to stream through, destroying your shielding. Concrete also stores heat rather than deflecting it, turning the bunker into an oven. And it requires powered ventilation to stay survivable, such as fans, expensive nuclear, biological and chemical filters, electrical systems, or manual cranking labor. When those systems fail, the shelter becomes uninhabitable. Meanwhile, something different was happening. Civilians in post-war Europe and America started experimenting with earth-covered shelters when they could not afford or access concrete. What they discovered matched what engineers later confirmed. Compacted soil outperforms concrete on almost every metric that matters for fallout survival. This was not invented by the military. It was discovered by ordinary people working with what the ground gave them. The Earth Arch shelter is the civilian engineering solution that the bunker industry never had an interest in popularizing. Crescent Kearney's research at Oak Ridge National Laboratory documented it. Swiss civil defense manuals approved it as a concrete alternative. FEMA's literature before the 1990s acknowledged it. Then the civil defense program was defunded in 1994, and the research got buried under decades of bunker marketing. Crescent Kearney's halving-thickness research at Oak Ridge established the baseline. Every 3.6 inches of compacted earth cuts gamma radiation in half. Stack 30 inches overhead, and you get 8 halving thicknesses. That reduces external gamma exposure to less than 0.5% of outside levels. Protection factors range between 200 and 500, depending on geometry and soil composition. Concrete has a halving thickness of 2.4 inches, slightly better per inch due to higher density. But concrete structures typically use 8 to 12 inches of material, constrained by structural engineering requirements and cost. That gives you 3 to 5 halving thicknesses. The Earth Arch uses your own excavated soil piled 30 inches deep at zero material cost, delivering 8 to 10 halving thicknesses. Here's what matters more than the math. Concrete cracks. Blast overpressure testing at the Nevada test site in the 1950s documented fractures in reinforced concrete at 5 to 15 pounds per square inch, the exact pressures encountered at survivable distances from nuclear detonations. Those cracks become radiation highways. A single fracture running through your roof destroys the shielding integrity of the entire structure. Earth doesn't crack. It compresses. Blast pressure distributes through soil particles rather than fracturing a rigid slab. The Earth settles, shifts, and remains intact. The arch shape is deliberate. Curved structures deflect blast pressure outward into the surrounding soil rather than absorbing force head-on. Same principle as a dome, same principle as an egg. The geometry converts downward and lateral blast energy into compressive forces. The arch handles easily, while flat concrete roofs absorb impact directly and transfer stress into the slab until it fails. Stack effect ventilation solves the problem that kills concrete bunker occupants, carbon dioxide buildup. Concrete bunkers require powered ventilation, fans, NBC filters, electricity, or hand cranking. If the power fails or the intake gets blocked, the shelter becomes a sealed room. It can kill occupants within hours. The earth arch shelter uses thermodynamics instead of machinery. One low intake vent near the floor pulls in cool air. One high exhaust vent near the apex pushes out warm, stale air. Warm air rises. Cool air enters from below. The cycle runs indefinitely with zero electricity and zero moving parts. Fallout dust is too heavy to travel through a low ground level intake. Particles settle before reaching the interior. No NBC filter is needed. No Kearney pump is needed. The arch geometry solves ventilation for free. The entrance design matters. A 90-degree turn in the entrance passage creates a radiation baffle. Gamma radiation travels in straight lines, it cannot turn corners. Fallout particles cannot travel around angles. The passage acts as a natural filter, blocking 95% of the radiation that would otherwise stream inside, while allowing air to flow freely. Underground at 6 feet, temperature stabilizes at the annual mean, approximately 55 to 60 degrees Fahrenheit across most of the United States. The soil mass buffers temperature swings. In summer, the shelter stays naturally cool. In winter, body heat alone maintains comfortable temperatures. Concrete stores heat like a thermal battery, becoming an oven in summer and a freezer in winter without powered HVAC. Earth regulates its own temperature using thermal mass, the same principle as a root cellar or a cave. Excavate 6 to 8 feet into a natural hillside. The slope does the shielding work on 3 sides and provides drainage. Water runs away from the structure, not into it. Face the entrance away from the prevailing wind. A hillside site means the structure stays hidden. No visible mound, no footprint from the road. Build the arch frame next. 3 options, 3 price points. A corrugated metal culvert pipe, 6-foot diameter, costs $400 to $500 delivered from agricultural suppliers. This is the turnkey choice. Cattle panels bent into an arch with earth bags cost $75 for the wire grid, plus the labor to fill bags with your excavated soil. Timber ribs notched into a curved profile require about $300 in dimensional lumber. Each option carries the same load once soil goes on. Waterproofing comes before soil. 6 mil plastic sheeting over the entire arch costs $40. Overlap edges by 12 inches. This layer is what makes the shelter last decades rather than years. Now the soil cover, 30 inches minimum, compacted in 6-inch layers. Use the dirt you already dug out. It costs nothing. Tamp each layer before adding the next. Compaction creates the shielding, not just depth. A hand tamper costs $30. Ventilation, 1 4-inch PVC intake. Pipe low near the floor, angled down so rain cannot enter. 1 4-inch exhaust pipe high at the apex extends above final grade. Mesh covers keep animals out. Total cost, $20. The entrance passage angles to create the radiation baffle. Fallout cannot travel around corners. The passage does the filtering work. Full breakdown, corrugated pipe option hits $450 delivered. Cattle panel option with waterproofing, hardware, and hand tools totals $255. Timber frame with all materials runs $475. Every version uses free on-site soil and your own labor. 2 to 3 days of work. Protection factor of 250 to 400. Federal adequate standard 40. You exceeded it by 5 to 12 times for the cost of a weekend trip. Run the numbers. 30 inches of compacted earth overhead delivers 8.3 halving thicknesses, external gamma radiation reduced to 0.4% of outside levels. The entrance baffle eliminates direct line of sight exposure. Partially buried sides add 4 to 6 more halving thicknesses on the walls. Final protection factor, 250 to 400 depending on soil type and construction precision. The federal threshold for adequate fallout protection is 40. A typical concrete bunker hits 100 to 150. You just exceeded both for $450 in materials. The limitations are real. This requires a sloped site and will not work on flat urban lots without major earth moving. The entrance remains the structural weak point under direct blast overpressure. This shelter is designed for the fallout zone, not ground zero, and it demands maintenance, annual checks on waterproofing integrity, ventilation pipe clearance, and soil settlement over the arch. But the physics being used here, mass blocking gamma radiation, arches deflecting pressure, earth buffering temperature, are now being rediscovered outside survival contexts. Eco-architects build earth-sheltered homes using identical geometry, eliminating heating and cooling costs. Off-grid builders use passive stack ventilation to avoid electrical dependency. FEMA's modern tornado safe room designs incorporate earth-covered arch structures. The same engineering that protects against fallout also protects against hurricanes and wildfires. The bunker industry built a business on steel and $40,000 price tags. 50 years of test site data proved 30 inches of dirt does the job better. The research was declassified decades ago. The materials cost less than a used refrigerator. The physics has not changed since 1960. Only the marketing has. The bunker industry sold the idea that survival requires reinforced concrete and a price most families cannot afford. Oak Ridge proved otherwise 50 years ago. 30 inches of compacted soil, shaped into an arch and covered with plastic, delivers protection factor 250 for what you would spend on a weekend camping trip. Mass blocks gamma radiation. Arches deflect blast. Earth buffers temperature. The engineering worked in 1960. It works now. The only thing that changed was who profited from telling you otherwise.